All right, hello. So today we're going to take some notes, and I have placed the blank note file up on Schoology, and I've also have put the filled in note file that I'm about to fill in on Schoology. And you can do one of two things to take notes. You can print out the blank one, and if I were you, I might print it, 2 pages for every one sheet of paper to make it a little bit like less paper. Or you can take notes as we go, like on your own piece of paper, like just handwrite notes of the examples. Like you don't have to write all the words or do everything, but just, to the best of your ability, kind of take notes on what you're seeing up there. And I guess you could also, when you're done after watching and doing the Ed Puzzle stuff, you could print off the notes that are already filled out if you'd rather do that. Anyway, here we go. So whatever your choice is. So f of -2, if you're given this function here. So this is what you're used to from Algebra 1, Algebra 2. If I want to plug -2 in here, first I set up a little framework, 3 times something squared minus 5 times something minus 7. So this leaves blank spots for every place that there's an x, and so we can put anything in there. I can put a smiley face, if I want to plug in a smiley face, whatever I want to plug in there. So in this case, I want to obviously plug in a -2, so I'm putting -2 right here. So then I work it out, and so, -2 squared here is 4, so this is going to be 3 times 4. Negative times a negative is positive 10, and then minus 7. So I have 12 plus 10, so 22 minus 7, so I end up with an answer of 15. All right, so you can also plug other functions into a function. So in this case down here, I'm going to be plugging 5x into all those blank spaces. So I'm just going to move down here for some extra space. So I have 3 again, blank space, squared, minus 5, blank space, minus 7. So even more in this case, you can see how I'm just going to put whatever you tell me to put there. I'm going to put a 5x. All right, so this just makes it a little bit harder, but I have 3 times, if you square 5x, you get 25x squared. Over here, I get minus 25x, and then minus 7. It actually makes it harder in one way, but also easier in another way, because now there is nothing left for me to really do besides this makes 75x squared minus 25x minus 7. Oops. You can't simplify it as much because you don't have like terms. All right, and so that would be your answer right down here. Okay. All right. So on to this other one, and then you guys have one you have to do. So let's see. So this one's a fraction. I want to do p of -3. So that means I would put -12. I have 2 something plus 3, and remember what I'm putting there is -3. So I have -12 over, I get -6 plus 3. So I have -12 over -3, so my answer is 4. All right, so in this next one, I have to put 10 minus 2x in that spot. So I have -12 over 2, blank spot, plus 3. And I know I'm plugging in, so I left a little wider space there, so I have 10 minus 2x right here. So just have a little stuff to work out. So I'm going to do that over to the side here. 2 times 10 is 20, 2 times -2x is -4x, and then plus 3. So if I simplify that down, I get 23 minus 4x for the bottom, for the denominator. So I have -12 over 23 minus 4x. That's all I could do, and that would be my answer for that, and up here was 4. All right, so I've given you one to do here, so I want you to try that on your Ed Puzzle. All right, so hopefully what you did, h of 3x, looks like this. So 6, we're going to put a 3x here, plus square root, I'm going to put a 3x squared plus 4, and I'm going to have 18x plus, I have the square root of, this turns into 9x squared, plus 4. And that's all I can do. I can't do the square root of these things. I just have to leave it since there's addition inside the square root. It's just locked into place. Unless you tell me an x to plug in, I can't do anything. So that is it. All right, so now we're getting into things where you have to be able to find the values of functions using a picture. So before we were I was giving you an equation and you plugged in a number. Well, I don't have an equation for this. This is just a polynomial. It's a cubic polynomial here that you see, this graph right here. So in cubic, remember, so x to the third. So if I want to see what g of negative 1 is, I would go, remember this is my x value right here, and I'm trying to figure out the y value. So if I go on the x-axis right here and I go to negative 1, here I am. It's actually, that's where the point is right now. So what I know right now is that there's a point on this graph of negative 1, 0. So that's all this question was asking me, was what's the y value when x is negative 1? So I'd say 0. All right, so g of 2 is pretty similar. So there's 2 on the x-axis, so that's a 0.20 on the red graph, so it's 0 also. Now g of 1 is a little bit different. So if I go to 1 on the x-axis, the graph isn't there like it was before. I have to go down here to find the graph. So there it is at negative 2. So the point on that graph was 1, negative 2, so I would say, oh, the answer is negative 2. All right, and then g of 0. So plugging in 0 always gives you your y-intercept, so that's kind of an important thing to note. So here's 0. I go up and find my picture, and there it is right at 2. Oopsie. All right, so this is for you to do. There's my parabola there, and I want you to find those two values. All right, so hopefully you found that h of negative 2. So negative 2 is right here, and that's going to produce this answer here, 1, 2, 3. So that one was 3. H of 1 was right there, so that would have been 0. All right, so now you have what are called piecewise functions. You saw these a little bit in class. So piecewise functions are just a graph that doesn't have one distinct equation. It's going to have a bunch of different pieces. So you're going to see on the next page a little bit, you can have 2 pieces, 3 pieces, 4 pieces, as many as you need. But what's happening here is that this one has 1, 2, 3 parts to it because I made them different colors. But if you wanted to write an equation for this, you'd need 1, 2, 3 equations to write this equation for this picture going on here. And we'll talk about that a little bit later. All right, but still I'm just going to read the graph and find the answers to these questions. So f of negative 1. So negative 1 is right there, so that's going to be using the blue graph. So I'm going to go up, and there's my answer, 3. F of 3. So 3 is over here, and I'm using the green graph, so it's right there at 0. And then the next one, f of negative 5. So negative 5 is over here on the red one right there, so it's at 0. F of 1, I go up, and there it is. So the answer is 3. And f of negative 2, it's actually kind of where the green and the, where the red and the blue meet, but there's no hole there or anything like that. So it's right at 0. That's the height of the answer. All right. Alrighty. So now I want you to do these two. Find me those two answers. All right, so P of 4. So here's 4 over here. And there's my graph right there at negative 2. And then negative 1, there's my graph right up here at 1, 2, 3, 4. 4, so I use each part. All right, so this is what piecewise functions look like. If you have this picture right here, this is how you'd have to define it. That's how you'd have to write it. It's really kind of gross, but it's not that bad. So let's just take a look and inspect it. You notice I have 1, 2, 3 parts. That's why there's 1, 2, 3 equations, or 3 parts to my equation. This first one, x squared, and this is only for parts of the graph where x is less than or equal to 1. So less than or equal to 1 falls right here, and it's everything to the left. So that's why the left of 1 to the left of 1, and including 1, there's a parabola, because that's what a parabola is. And then between 1 and 2, but not including at 1, there is this number. So that's why, remember, this is always y equals. So this graph right here is y equals 3. So y equals 3 exists right between 1 and 2. And then after that, I have the equation y equals x. So if I have y equals x, remember y equals x is a line like that. So that's this line coming right here, but it only exists after 2. So starting right after 2, you have that line. And if I continued it on, you could see that it's the same line that I was talking about, but anyway. All right. So I could, if I wanted to do something like if I wanted to ask someone, hey, what's this function's value at 3? I would have to look at my categories. 3 falls in that category. And so I would say, hey, let me plug 3 into there. So actually the answer is 3. Because also when I go to 3 and I go up to the graph, there's my answer, 3. All right. if I wanted to say, hey, what's the function's value at -2? So -2 falls into this category, so I would use this equation. Well, -2 squared is 4. Look at my graph. -2 is 4. All right, so that's what we're going to do here, and we're not going to use a picture at all. We're just going to use the equation itself in this next example. All right, so in the future we might have to make some graphs of these things, but for now we're just going to be able to plug in some numbers. All right, so h of -4. So h of -4, if I think about -4 falls into this category right here. It's less than -2. So I'm going to plug -4 into this problem right there. So 2 times -4 minus 8. So it'd be -8 minus 8, that'd be -16. All right, 9. So let me see, 9 falls into that category. It's greater than 8. So I'm just going to use this number right there. There's nothing to do. The answer is just 6. All right, h of 0. So 0, let's see, falls into this category right here. So that means I'm supposed to plug 0 into this problem right there. So if you put 0 in there, 0 squared is 0, and 0 plus 10 is 10. So I get the square root of 10. And h of -2. So -2, so it looked like it was going to fall there, but actually -2 is defined right here. So it means I have to plug -2 into this problem right here. So if I square -2, I'm going to do the square root. -2 squared plus 10. So that'd be 4. 4 plus 10 is 14, so the square root of 14. Alrighty. So, whoops. I thought I had one for you to do there. Maybe I put it on the wrong page. Well, never mind. I guess I didn't. I'll make you do that in class. All right. So in class, we used set notation. Set notation looks like these guys down here, and I had you do that domain and range activity for that. But we also have to use interval notation. Interval notation is actually, I think, a little bit easier, but here we go. So with set notation, if I was going to define this right here, I would say, oh, x is between, and it looks like it goes from 2 to 9. So I'd put 2 to 9. These are filled in, so I'd put equal to on those things. All right. But if I was doing interval notation, I would put 2 comma 9, and I would just put brackets to mean that it's equal to, and that would be it. All right. This one right here, this is going from 1, and this is going off to infinity. So if I was doing set notation, I could say something like, x is between infinity and 1, or I could say x is greater than 1. Either one of those is the same thing. But if I'm doing interval notation, I want to say 1. Remember, I put a parentheses because I don't want to include 1. It's not a filled-in hole. And I put comma infinity. Now, infinity always gets a parentheses because you can't ever get to infinity. It's just unreachable. All right, so this next one right here, if I'm going to write the interval notation, I would say everything less than 10. So remember, this is going down to negative infinity. So interval notation is very easy. You just say, where do I start? Where do I end? So I go negative infinity, and my higher number is 10. So it always goes lowest to highest. 10 is filled in, so I put a bracket. Infinity never gets a bracket. So that's it. Now this one is broken up into 2 pieces, and I forgot to mention up here. So basically I have an or situation right there. I have everything less than 5 or greater than or equal to 8. So what we're going to use is this little symbol right here. This is a union symbol. So it's a union symbol. It also means or. Okay, that's how, like, the layman's terms. All right, so we're going to say, let's see, this goes from negative infinity. It stops at 5. So I'm going to name that negative infinity, comma 5, parenthesis, because it's not filled in. This is always parentheses. Or, and then I'm going to say it starts at 8, and this one goes off to infinity. So parentheses on infinity, 8 gets a bracket, though. All right, so I'm going to just write these right here, and then you guys are going to do letter D. So interval notation, everything less than or equal to 0. So 0 is the high number here. So 0 goes on the right, and if I'm going less than or equal to 0, that goes down to negative infinity. 0 gets a bracket because of the equal bar, and infinity never does. All right, here, greater than negative radical 2. So negative radical 2 is the lowest thing, and the highest thing is infinity. So negative radical 2, comma infinity, parenthesis here because there's no equal bar, parenthesis there. All right, or, so I'm going to need a union set. So I have this category less than 7.5. So that's going down to negative infinity and stopping at 7.5 for the highest, parenthesis, because no equal bar, parenthesis here always. Or this one starts at 10 and goes up to forever. So 10 is the lowest thing in that category, and then up to infinity. Always parenthesis. This one gets a bracket though because of this equal sign right here. All right, this one is for you to do. All right, so this one right here is a nice contained thing. It kind of looks like this one up here. So it starts at negative 4, goes to 12. 12 gets a parentheses, and negative 4 gets a bracket because of the equal bar. All right, so the last thing we have to talk about is domain. So when we define something like certain functions, you can plug any number you want, okay? So then their domain is all real numbers. But certain functions have restrictions on what you're allowed to plug in because of certain restrictions, like you can't have 0 in the bottom of a fraction, or you can't have a negative inside of a radical, things like that. All right, so to plug them in, they have a domain that is not necessarily all real numbers. So for instance, when you have this function right here, like this guy right here, this is a polynomial. Polynomials, you can plug anything you want into a polynomial, okay? So its domain is all real numbers. So that double R there is what we say for all real numbers. Or you could say negative infinity to infinity. That's another way to write all real numbers. But a function like this next one, g of x equals x minus 4 over x plus 7, is going to have a problem with a certain number, right? Remember, the biggest thing about a fraction is the bottom cannot equal 0. So think about for a second, what number would x have to be for the bottom, the denominator, to be 0? All right, so hopefully you came up with the number negative 7. I can't use negative 7. So there's a couple ways you could write it. You could say the domain is all real numbers, comma, x cannot be negative 7. You can write it like that, or you could break it up. So basically what's happened is that here's negative 7. If I kind of draw it out, here's negative 7. You can go everything above, everything below, but you just can't be negative 7. So you could say this, negative infinity up to negative 7, parentheses, or then start at negative 7, after negative 7 again, up to infinity. So that's doing everything except negative 7. All right, so I'm going to do these 3 here, and then you're going to do the last one on the next page, and that's it. So, and this problem here, letter A. So I have an issue here because I'm not too sure about this part down here. I have to fix it up before I can see what numbers are not going to be allowed. So we need to factor it. All right, so I got x and x. What multiplies to 20 and makes 8? I think I'm going to use 10 and 2. And I'm going to write that a little bit bigger because it's looking a little small. Let me get off this fat pen. All right, so x and x. If I do 10 and 2. If I do a negative 10 and a plus 2, oh my God, what am I writing? That works out to negative 8x and negative 20. All right, so there's 2 numbers I will not allow. So this one, I think I'm going to choose to write it like this. That would be perfectly fine. All right, so my domain is all real numbers where x cannot be 10 or negative 2, because those 2 numbers would cause the bottom to be 0. Okay? All right, so here, think about a square root. You cannot have a negative inside the square root. So I'm going to make up a little problem for myself to solve. This piece inside here, 2x plus 6, has to stay positive. So that means that 2x plus 6 has to be greater than 0. Now think to yourself, could it be equal to 0? Yes, it could, because the square root of 0 is 0, so I am allowed to have 0. All right, so let me solve this. Take away 6. Get 2x is greater than or equal to negative 6. Divide by 2, I get x is greater than or equal to negative 3. So there's my domain right there. That's in set notation, really. So if I want to write it in interval notation, I would say, hey, start at negative 3, go to infinity, parenthesis there, bracket here. So this is just another way to write it. Kind of easier maybe sometimes. All right, so last one here, letter C. So I have a square root and I have a fraction. So hopefully you notice the number 9 is not going to be good. 9 minus 9 makes the bottom come out to 0. So I don't want to use 9. So 9 is a no-no. Also, I have another situation. It's a square root. So this expression right here, just like in my last problem, t minus 9, t minus 9 has to be greater than 0. All right? So that means if I solve that, add 9, t has to be greater than 9. So not only does t have to be greater than 9, it can't equal 9. So I think I have my answer. My domain is everything from 9 up, but do not include 9. So basically, this right here is kind of similar. Okay? All right, this last one here is for you to do. This one right here. All right, so hopefully here for your domain, you put everything but 2. So you could have written it one of two ways, and I did ask for an interval notation, so we're going to write it like that. So you could have said everything but 2, but an interval notation, remember, so I can't use 2, but I can use everything above it and everything below it. So that's from negative infinity up to 2, parentheses, parentheses, or start back after 2 again, up to infinity. So that would be